Here's number 30 and our last for our review, so that's kind of good news. And this one is with integrating to infinity. So does it converge or does it diverge? So what we do is we're thinking in terms of limits. We're going to integrate this part in here, and then our limits are 0 to infinity. But what we do is, remember, we sort of do a trick because we really can't integrate to infinity, so we just say, let's integrate to some big number m, or whatever they call it. I don't know. Each book calls it something different. And then we're going to take the limit as the m goes to infinity. So again, it's just a little mathematical trick. Fool ourselves a little bit. And then we do 9e to the minus 9x dx. So when we integrate this, what do we get? So e to the minus 9x, we get e to the minus 9x. Remember, divided by, so just using that rule, whatever this is, e to the x, e to the ax, when we integrate that, we get e to the ax divided by a. Okay, so that's something to remember. Because when we take the derivative, the a is going to come down, and that gives it something to cancel off. So over 9, negative 9. We still have this 9, so then they cancel. Okay, but we have this negative. So, and we still have the limit as m goes to infinity. And we go from 0 to infinity. And we just really want to know, calculate the value of the improper integral, select the correct choice below, and if necessary, so the improper integral. So if it diverges, we don't have to. If it does converge, we can calculate that. So we plug in, so let's clean it up a bit. What we have is the limit as m goes to infinity, e to the minus 9x over, no, the 9 canceled out, just a minus here. Okay. And our limits are going from 0 to infinity. Okay, so we plug in infinity, or, well, sorry. We don't do that. That's crude. It's really what we're going to think we're doing anyway, but okay, m. So we end up with the limit as m goes to infinity of negative e to the minus 9m minus e to the minus 9 times 0, which is actually minus, so that makes a plus, e to the 0 power, 0 times negative 9 is 0, which is going to be 1. And then this limit here, now notice, because we've got this negative exponent, what we really get is the limit as m goes to infinity, 1 over, we'll put our little negative out here, e to the 9m plus 1. Well, if we let m go to infinity, this e to that, it's going to, e to some power is going to become so huge, and then 1 divided by a huge number goes to 0. The limit goes to 0. So we can say this whole thing converges, certainly, and it goes to 0. So we end up with 0 plus 1. So we can check box A. And what's the limit? 1. Kind of cool. Now, to verify that a little bit, let's go with our graphing calculator. Let's go to y equals. Let's put this function in there. I'm going to show you how we can kind of cheat this a little bit. Not cheat, but get a good estimate. Let's put it that way. So we put this in here, 9. Shifted natural log gives us e to the minus 9x. That's all up there. So So remember, we're going to look at that graph from 0 to infinity, not quite infinity, but we are going to go out. So let's go out to, let's say, 10,000. Now, noticing that as a function, we probably don't want our y value very high. I think 1, 9, this becomes something, I don't know, maybe 10. Let's just guess. And then let's see if we see a graph. So we're going up to 10. I would have, maybe we see 9e to the minus 9. So at 0, that's 1. Oh, it should be 9. We should be seeing something. But the deal is, we don't see much because well, I don't know. Let's yeah, I think because we're so far at 10,000. So let's make this 1. Let's make our y, because we're testing it out. We did it. It should only have an area of 1. Let's see what happens when we do that. See if we even see a graph. 9e to the minus 9x. Oh, let me do this. What should I do? Well, let's go ahead and go to the graph. Let's assume it's there. So let's go second calc. Let's go number 7. I think probably because I'm so far zoomed out. The lower limit is 0. The upper limit is 10,000. And we might not be able to see anything because it's got to be all down here. It says that it's 0. Wow. Aren't we glad we did this? Let's go from 0 to 10. And I'm guessing... Oops. Let's see, what did I do? Oh. I think 10 should be about y max. Yeah, we see it dropping off really quick. So maybe I went out too far. So let's go from, you can see it's more area than 0. Lower limit 0. Let's do an upper limit of 10. Filled it in there. Yeah, so that's the thing is, and so we can go further out and we don't add anything to it. I don't know why I wasn't calculating it sooner. Sometimes you just, but even just going from 0 to 10, it's only 1. And then what happens after 10, you just don't add anything more. That's what's happening. Okay. Sorry if that confused anyone, but it's just kind of, we find these things, we explore, and sometimes it doesn't give us what we want, but we come back. Okay, so that's number 30. Keep studying. Work this several times, work through the test, because each time you go through the review, you get slightly different problems, and it'll help the more times you. In fact, if you could work each one 3 times, I know that's 90 questions instead of 30. But by the 3rd time you do something, it becomes your own. You own it, and you'll do better. It just happens that way. So good luck, and I hope the best of success for you. And once you get through this course and go on to the things, I just want you to know it's been a pleasure working with you, and I'm hoping for your great success in your future pursuits. Thank you so much.